Um, Although electric cars are recognized for their speed, the Tesla is Plaid is the fastest production car ever to accelerate. A number of variables contribute to this, but the three unique electric motors in the battery pack are what really make the Plaid what it is. Before we go any further, let us first make sure that you subscribe to our channel and give this video a big thumbs up. If you've ever used a compass, you know that the needle always points north, aligning with the Earth's magnetic field. If you bring a magnet close to the compass, the needle spins to align with the magnet, which is the strongest force of attraction. If you move the magnet around the compass, the needle will continue to spin. This is an example of induced rotation using a magnet. On the other side, an electric motor rotates by using the force of push and pull, but electromagnets are needed to keep the motor rotating continuously. Although copper is not magnetic, it is incredibly conductive. And when electricity passes through it, it turns into an electromagnet, giving us amazing control over the magnetic field. While an electromagnet's magnetic field follows the direction of the electrons moving through the conductive material, permanent magnet like the one on your fridge has a physical north and south pole that cannot be changed, although there's a lot of high-level engineering involved. Understanding fundamentals of Tesla's electric motors is not too difficult. The design of Tesla's induction motor is based on Nikola Tesla's invention, and the motor's operation depends heavily on electromagnets. By conducting electricity through conductive materials, we can harness the power of magnets to create rotation, which enables electric cars like the Tesla Model S to accelerate the reversal of electricity flow and the reversal of the magnet's poles. This means that depending on the type of use you give them, electromagnets can swing both ways, and you don't have to physically turn the magnet inside the electric motor to reverse its poles. Both the rotor and the stator, the rotor is an iron core surrounded by rows of permanent magnets that run lengthwise. For simplicity, let's say there are 4 rows evenly spaced around the ring, top, bottom, left, and right. Each quarter of the ring has an alternating pole. So they go north-south as you go around the stator. Moreover, the entire ring is surrounded by a tube of electromagnets made up of many coils of copper wire that run lengthwise. Each coil of wire is an individual electromagnet that can be turned on and off and have its polarity flipped simply by controlling the flow of electricity into each coil by placing the rotor inside the stator station area. Anytime you put 2 magnets near each other, there will be a natural push and pull, and the opposite poles will pull towards each other. While the poles will push away, but once the initial alignment is complete, the rotation will stop. To maintain that rotation, all you have to do is constantly move the north and south poles of the stator magnets around the outer ring. And again, you do that by controlling the direction of the electrons flowing through the coil of wire by moving the south pole of the stator around. In a circle, it'll pull the north pole of the rotor along with it, and conversely, at the same time, the south pole at the stator will push the south pole of the rotor as it moves around that ring. That constant force of push and pull will spin the rotor, and the faster you move that magnetic field around the stator, the faster the rotor will spin. When you see the Tesla logo, it's a cross-section of an electric motor. The top curving line is the stator ring, and the pointy T shape is a slice of the rotor. Hopefully this explanation made sense and was mostly accurate. The next discovery Sandy Munro made during the disassembly of the Model SS Plaid motor concerned the bearings. These are what enable the rotor to spin smoothly inside the stator, and in earlier Tesla motors, they were just standard ball bearings. However, in the Plaid motor, Tesla has upgraded to ceramic bearings. It may not be textbook worthy, but it should be sufficient to make the main point. Compared to steel bearings, ceramic bearings are more durable, have less friction, and can withstand higher temperatures. Finally, Sandy Munro discovered that the plated motor uses a new type of insulation material. In previous Tesla motors, the insulation was made from a material called Nomex, which is frequently used in the aerospace industry. However, in the Plaid motor, Tesla has switched to a new automated process for winding the wire, which allows for faster and more precise winding and can help to improve the performance and efficiency of the motor. This is an interesting discovery Sandy Munro made regarding the wiring inside the Plaid motor. Peak polyester ether ketone is the replacement substance that Tesla is using instead. Peak is a high-performance plastic with exceptional chemical and thermal resistance. making it perfect for use in high-temperature applications like electric motors. According to a recent article, Tesla has made efficiency a top priority in their manufacturing processes. This is demonstrated by the fact that every automobile uses the same basic part and doesn't waste time modifying the board's printing because they all just state Model 3. The single modification for the Plaid inverter. The board is actually an explosive fuse that acts as a tiny bomb firing two pushers straight out that physically break two of the bus connectors that link the power from the inverter to the motor. This ensures that the motors go completely dead in an instant. If something catastrophic happens to a Model S Plaid, though it's unclear what would cause this fuse to fire. Additionally, all three motors in a Plaid vehicle are exactly the same, making it the most efficient choice in production. Tesla even invented an inverter for the Model 3 that they like so much that they implemented it into every motor in their lineup. The report's conductor, Sandy, discusses the benefit of having two motors in the back. Power means more using a single motor per wheel, simplifies things. Using a single motor to drive two wheels instead of a differential. The only component between the Plaid motors and the rear wheels is a single gearbox, which is required. Since Tesla doesn't have a transmission and only has one set gear ratio, adding a differential or other component between the motor and the wheel increases the possibility of energy loss due to friction or the gear set. Interestingly, the Plaid motor stator is exactly the same as the one found in the Model 3Y motors, optimizing production efficiency. However, the rotor has undergone major modification. Although the hosts were a little perplexed by it, Sandy and his crew had never seen a design like this inside an electric motor. Tesla uses car-shaped laminate sheets to create the iron core of the rotor, with 529 of these stars making up the core and creating 6 rows of magnets around the rotor. The magnets are then capped off by another laminated piece that looks exactly like the Tesla T logo. These caps don't connect to the core of the rotor and are just held on by the magnets themselves. According to Tesla, the floating caps and laminated star construction result in a 25% boost in power and torque capacity. To test the Plaid motor, note that its permanent magnets are also substantially more potent than those of a normal electric car motor, such as Tesla's standard motor. When measuring the force necessary to remove a bolt from the rotor magnets of different models of electric cars, Monroe, and an unconfirmed source discovered that the Plaid required 151 newtons of force, while the Model I required 112 newtons. While the Mustang matching needed just 81 newtons. The BMW i3 needed 93 newtons. This shows that the magnets inside the Plaid rotor are approximately twice as strong as those in the Mustang Mach-E's rotors, and over a third more powerful than those found in the Model I and Model 3. Even though the subjects are complex, becoming knowledgeable about the plant's capabilities and technology can increase how much fun driving an electric vehicle can be. Lastly, they express their gratitude to the Patreon supporters for helping them create high-quality content. That pretty much sums up this video. Thank you for watching, and don't forget to give it a big thumbs up. See you in our next one. Enthusiastic host encouraged viewers to share their thoughts that video and to let them know if any information was incorrect. They also ask viewers to give the video a big thumbs up and sign up for their weekly newsletter.